So we are going to investigate baking soda as a selective post-emergent herbicide in St. Augustine lawns. First thing we need to do is gather up some supplies. Household baking soda. I'm using baby wash, unsulfured black strap molasses, and a pair of pantyhose. Used is fine. You can also use socks. Take the baking soda, put it in the pantyhose, tie knot, and that works for distributing the baking soda. Take a solution of 2 teaspoons baby wash, 1 teaspoon of molasses, mix that with 2 cups of tap water, and put that in a spray bottle. There's nothing scientific about that mixture, it just happened to work. And you're left with a spray bottle with a soap molasses mixture and a pair of hose with baking soda. You can pat the baking soda out or jangle it like a yo-yo. We're going to make sure that the soap molasses mix doesn't have any effect on the dallisgrass. There's no reason that it should, but we spray it on and take record over time. And over several hours, there's no noticeable effect, immediate effect, from the soap molasses mixture. So we can verify that there's no cause for damage from the soap molasses. First test site is a St. Augustine and Bermuda lawn. It gets full sun and there's no supplemental watering. It hasn't seen rain in about 3 weeks as of this test. First site, we're going to dust with baking soda and then water the baking soda in with tap water so that there is no residual baking soda on the leaves. And monitor that to see if just having the baking soda in the ground around the roots affects the plant, and it really doesn't look like it does significantly over the course of a couple of days that this test was run. Second test is also dallisgrass. We're going to spritz it with plain tap water and then dust it with the baking soda. With the tap water, there's no soap in it, so that you have large water beads, which you can see in this photograph, because there's no surfactant effect from the soap. We monitor that after we've dusted it with baking soda, and you can begin to see damage to the leaves, especially on the margins, on the edges. It's starting to turn dark and then turn black. You can also start to see some damage to the Bermuda grass that's mixed in, not so much with the St. Augustine. Third test case, we're going to use the soap molasses mixture, spritz it on, and then dust it with baking soda. You can see that we have very fine droplets of solution, and it's been dusted with the baking soda. Interestingly, it gets more white and more noticeable. That's not an artifact of the photograph, it actually happens. And you can see the darkening along the perimeter, along the margins of the leaves. They turn black. And again, this is leaf damage, not root damage apparently. You can see it looks moist there, that's due to the dew. And here we are coming up in 2.5 days worth of damage. We're seeing the Bermuda grass turn brown. The blackness on the dallisgrass is starting to turn brown as well. And you can also see there's an effect on the seed heads. Now we're going to move on to crabgrass in a St. Augustine lawn. This is my lawn in a test site. Most of the crabgrass is on the right side. It gets filtered shade and regular, deep, and infrequent watering. You can see 3 test sections, one on the left, center, and on the right. It was all spritzed with soap molasses, dusted with baking soda. In the middle, an extra spritz after the baking soda was applied, and on the right hand side, that's predominantly St. Augustine grass. Test H1 is predominantly crabgrass. You can see the baking soda has been applied, and again it turns more white, possibly because the baking soda comes out of solution as the solution evaporates. It doesn't turn as brown as quickly as it did with the dallisgrass in the full sun, but you can see the same effect, darkening on the margins of the leaves, blackening, and the leaves begin to die. Start to get very straggly. Here we are, and then we washed off all the baking soda, and you can sort of see that the black is the crabgrass, the green is the remaining St. Augustine. You can see a St. Augustine stolon running through the middle of the picture. We lift that up just to take a look, and indeed it is reasonably healthy. The very tips and young leaves have been somewhat damaged. In the middle test, again, we spritzed it with spray, dusted it, and then spritzed it again, trying to get more of the baking soda into solution. It initially had a faster effect than without the second spritz, but that difference in effect really went away within 5 or 6 hours. Again, the same pattern, darkening on the perimeter of the leaves for the crabgrass, not as much an effect on the St. Augustine, although the St. Augustine does show some withering, for lack of a better word. Here it is, the baking soda has been washed off, and the crabgrass is black. The remaining green grass is St. Augustine. The third test case is spritzed with solution, dusted with baking soda. The majority of the grass in this photograph is St. Augustine. You can see that the crabgrass portions begin to turn black, and the St. Augustine grass is not as healthy as it was. There is some die-off, but not nearly to the case of the crabgrass. Then again, we washed off and rinsed the baking soda off the grass, and after drying out a bit, you're left with some strands of St. Augustine amid the dead crabgrass and dead St. Augustine as well. So to review what it looked like, here was the healthy stand of the 3 test patches at the beginning of the test. Over time, you can see the 2 sections on the left are being more severely affected than the section on the right. The 2 on the left again have more crabgrass. Also notice that along the bottom edge of the test site against the sidewalk where the baking soda was not applied very well, the leaves of the crabgrass were not greatly affected. So the question becomes, why does the baking soda affect the dallisgrass and crabgrass and not the St. Augustine to the same degree? One idea is that the sodium in the baking soda has some effect on the osmotic balance in the leaf structure. St. Augustine may be more resistant to that because it is known for use in southern coastal areas for salt resistance. Now, so we took some table salt, put down the spritz, and to look at what kind of leaf damage we would see just from straight table salt. Here it is, our test site. It's dallisgrass, and over a little time you can see the margins are turning dark, just like we saw with the baking soda. Not as fast, not to the same degree. That may just because the table salt is fairly large in grain size compared to the baking soda. Here you can see the comparison of baking soda on the top to table salt on the bottom. Again, it's just an issue of degrees of how much damage was done, but they're very similar in how they appear.